Okay, on your mark, get set, go. Sum and difference formulas for sine and cosine and tangent. We've already talked about there's nothing easy in math moving forward, but we will take it step by step and show you the bare bones basic. So if you want to see it, come see me later. Right now, I can tell you this. If you want to determine the sine of two angles that are added together, A plus B, and now do not write this down. Sine of A plus sine of B. That is not what it is. You do not distribute. This is not sine times A plus B. It's sine of. It's an operation. You can't transfer it like multiplication over addition and subtraction. Turns out it actually ends up to be the sine of A times the cosine of B plus the cosine of A times the sine of B. That is the result that we get. Okay? So you ask the y is the proof. Do you want me to show you the proof that only 10% people understand it takes a half an hour? Then you have to accept as true. Get my point? Okay, so find the exact value. Let's start with a very basic problem. That looks kind of confusing. Sine of 23, cosine of 67, those aren't nice values. But I do see that it's in a form that's similar. Doesn't this look like the formula we just wrote down? It looks like this thing. It looks like sine of A times the cosine of B plus the cosine of A times the sine of B. That's what it looks like. And that's the same thing as what? Sine of A plus B. So, Zizi sees it. She says it's the sine of A plus B. All we have to do is decide what is A and what is B. In this problem, what is A? 23. And what is B? If only I knew what 23 plus 67 was. 90. And so the sine of 90, oh boy, could we actually find out the sine of 90? 90 degrees, what's the terminal point up there? 0, 1, so what is the sine value? Assign the x value or the y value?
Y.
And at this moment, you are realizing that you're going to have to start to remember things that you learned previously in this class, which is what makes math difficult for a lot of people moving forward, is they tend to remember not very much. So how do we make that easier? Again, we go back to the unit circle. You are finding 90 degrees, that coordinate. In fact, the first day we started this class, we talked about those points. I said you were going to have to do that over and over again, right? Well, there it is, right there in front of us. Sine of 90, it's the y value, it's 1. What about the cosine formula? Oh, by the way, for the sine formula, if it's subtraction there, then it's subtraction there. Suppose you have the cosine of A plus B. It turns out that that works out to be the cosine of A times the cosine of B. Yep. Instead of plus, it turns to minus sine of A times the sine of B. We have addition here. If it's subtraction, then it turns to addition down there. The signs are opposite. You don't have to remember those formulas. I have a sheet that I've created for you right on the back. We've already done these. We're not doing these. You did area last unit. You did law of cosines last unit. You did the law of sines last unit. The Pythagorean identities, We've talked about that extensively. The even and odd identities, we've talked about that. We're going to get rid of the cofunction ones because we don't have time, unfortunately. But sum and difference, here you go. It's right here. This is an area that you are going to have to be able to use come time for the test. Everybody see that? Okay, so let's make use of it. Let's do a second problem, okay? Look at problem number 2. Whoop, where am I? Where'd you go? Right there? There we go. Letter B, excuse me. Cosine times cosine plus sine times sine. That looks similar to what I just did, doesn't it? That looks like the cosine of A times the cosine of B plus the sine of A times the sine of B. It has that form to it, which is the same as the cosine of what? Yeah, it's going to be the cosine of A minus B. So when we convert it to that, it changes from plus to minus for cosine. And as Aaron said, we are going to plug in 2 pi over 3 for A. And we're going to plug in 5 pi over 12 for B. What to do now? Common denominators. 2 pi over 3 is the same as 8 pi over 12. So cosine of 8 pi over 12 minus 5 pi over 12 is equal to the cosine of what? Three pi over 12. 3 pi over 12 is the same as pi over 4. Looks like we're in radians. Pi over 4 is how many degrees? 45. Do you remember the cosine value of 45? Close. Looks like we better write them down somewhere. I'll put it up here. This is the thing we never want you to have leave your brain. This is 1, 0. This is 0, 1. If you put a 45, it's root of 2 over 2, root of 2 over 2. If you put a 30-degree angle, this is the root of 3 over 2 and 1/2. And if you put a 60-degree angle down, that is a 1/2 and a root of 3 over 2. We all remember producing that, correct? So that's something you've got to be able to generate on your own. I don't give those to you. You're going to be expected to know those because we mastered that content once before. We had very high scores on that test. So we go back. The cosine of 45 is root of 2 over 2. Nope. I see it. It comes up each year. I always forget that it comes up. So I'm going to do my best. You ready? I need you to lean in and focus. You ready? Okay. See how I have cosine of that plus that? That becomes all of this. This thing becomes all of this. So all of this becomes just that. So I didn't just do the cosines. You see, this thing becomes the cosines and the sines. That means the cosines and the sines becomes just that. In make-believe world, yes. Yep, let that work for you. But mathematically, that is absolutely correct. Okay, so yes, thank you. All right, very good. All right, so let's try a couple problems you're going to see on the test. We have sine of 15 degrees. We don't have a nice value for sine of 15. This is where it gets kind of exciting as we investigate what to do. This first angle here was 30. This was 45. This is 60. We've got 90. We've got 0. Those are the angles that we're used to working with, right? We don't have a 15-degree angle, so what do? Yeah, when people like, just let's cut it in half, right? Yeah, just cut it right in half, right? And it would be great if it worked like that, but it doesn't work like that. So we got to figure out what to do. So let's be smarter, okay, than that part of the problem. Let's see what we can figure out, okay? And a lot of people will automatically say, well, let's just type in our calculator, sine of 15. Like if I type that in, am I going to get a value? Yeah, and you're going to get an estimation, but let's all agree, I've got 6th grader Tenley, smart little kid, but does she know trigonometry? No, but could she type in and get sine of 15 on her calculator? Yeah, doesn't mean she knows a dime about trigonometry. Agreed? She has no idea. So what did they do back before they had calculators? You can actually go to ancient Babylon and find tablets where they made trigonometric tables. They have these written down from thousands of years ago. If they needed to come up with a new value like sine of 15, they may use this kind of a formula. Let's figure out what it is. In order to figure out the sine of 15, which is an unknown value to us, and by the way, exact value, so no calculator, we need two angles that either add to 15 or subtract to 15. Can you think of two angles that we know that subtract to 15? 45 minus 30. Now, some people say, well, I would like to use 60 and 45. That's fine. You can use sine 60. You can use 60 and 45. I'm not going to because that one was said first, but you'll come up with the same answer either way. And so now we expand that. So let's expand that using our formula up above. This becomes sine of 45 times cosine of 30 minus cosine of 45 times the sine of 30. Now let's find the exact values. Sine of 45. Yeah, so somehow we got to come back to these values all the time, right? So sine of 45, that's the y value, and that's going to be root of 2 over 2. Cosine of 30, root of 3 over 2, minus cosine of 45, root of 2 over 2, and sine of 30, 1/2. So I'm going to simplify this expression. The root of 2 times the root of 3 is the root of 6, and 2 times 2 is 4. The root of 2 times 1 is the root of 2, and 2 times 2 is 4. So on top, you get the root of 6 minus the root of 2, all over 4. That's the exact value. And as I try to check, if I type in sine of 15, you can see what I get. And if I try to type in the root of 6 minus the root of 2, and I want to take that and divide that by 4, they are identical, aren't they? Oh, that's pretty impressive. Tenley's a smart kid, but she can't do that. You guys can because you know how to do trigonometry. You're really smart. Talk to your partner. What should you do with the next one? Talk. What should you do? Talk. Okay, what was your first thought? Okay, so you want to expand it out, but 7 pi over 12, I don't even have a reference for what that is. Like, what is that? That's a radian, right? Would it be easier to work with it if it was in a degree? What is 7 pi over 12 in degrees? Do you remember how to do that? Isn't it amazing? Isn't it amazing? We used to do this all the time, right? Very good. You multiply by 180 and you divide by pi. So if you take 7 pi over 12 and you multiply by 180 over pi, that's your conversion. You're going to have to be able to convert between radians and degrees just like you did in the first unit. Notice what happens here is the pi's cancel. 180 divided by 12 is 15, and 7 times 15 is 105. So this is the cosine of 105 degrees. So Allie and Aaron are correct. We will expand it, but what are two angles that either add to 115 or subtract to 100? I'm sorry, add to 105 or subtract to 105. 60 and 45 will work just fine. So cosine of 60 plus 45. Now, if on the test you do the cosine of 60 plus the cosine of 45, I'm going to take the spoon that I have in my hand for me and my ice cream, and I'm going to stab it in my eye. You all get that? Help me save my eye. Don't let me lose my eye. You got to expand this out. Cosine of 60, cosine of 45, plus or minus. Minus, it's opposite for cosine. Minus sine of 60, sine of 45. Good. That's how we expand a cosine sum and difference formula. So I need the exact values of sine and cosine of 60 and 45. Again, if we look back at our drawing that we generated here, you can see you're living at the 60 and the 45. Cosine is the x value, sine is the y value. So somehow you got to be able to produce that. I don't give that to you on the test. That's something you should know and you need to know because we're going to use it moving forward. What is the cosine of 60? 1/2 times root of 2 over 2 minus root of 3 over 2 times root of 2 over 2. Looks similar to the last one, slightly different. We have the root of 2 over 4 minus the root of 6 over 4, otherwise known as the root of 2 minus the root of 6 all over 4. Now, Erin's taking the test. Her calculator broke. She can't really check her answers. She's trying to figure out, do I know if I'm reasonable? And she uses some thought here. She says, well, is that going to be positive or negative? Everybody agree negative? Okay, well, let's think about this. It's cosine of 105 degrees. Is 105 in the first quadrant or the second quadrant? Second quadrant, is cosine positive or negative in the second quadrant? It's negative. So you can see as you tie multiple things together, folks, that's what, like, you're becoming smarter. You're actually building neurons in your brain. So we've checked our answer. We feel like we're pretty good. Let's do the last one, which is the tangent formula. Suppose you have tangent of A plus B. Wouldn't it be nice if they gave us an easy formula for once? Like suppose tangent of A plus B was just the tangent of A plus the tangent of B. Wouldn't that be awesome? No, you can write that down. Because that's the top. The bottom is 1 minus the tangent of A times the tangent of B. Got you there, didn't I? Nobody during second or third hour laughed at my joke. Only you guys laughed. Why is that, Zizi? Oh, they saw it through me. Because you already looked at the sheet. You knew it was coming. All right. All right. Whatever. Way to steal my thunder. All right. So if this is minus here, it's a minus here, and then a plus down there. So the top sign is the same. The bottom sign is opposite. You good? Okay, so let's execute this. Tangent, 19 pi over 12. First, let's convert that to degrees. How do I do that? 19 pi over 12 times what? 180 over pi. Pi's cancel. 180 divided by 12, that's 15. 15 times 19. 285 degrees. I do not give you this on the test, but you need two angles that we know that add to the 285. I'm going to write them down. You tell me when you find something that you feel like adds to, sorry about that, something that adds to the 285. We got 90, 120, 135, 150, 180, 210, 225, 240, 270, 300, 315, 330, and 360. All right. Got to add or subtract 285. What do you got? Good. 135 plus 150. We got another one. 60 and 225. Good. So we got another one. 240 and 45. Good. We got another one. 315 minus 30. Good. Everybody see that there's a number of them? Some are better than others. Like they all work, and I used to just let people figure it out on their own, like which ones they should choose. Trust me, there's ones that work a lot better than others. You want to know which ones work better than others? Okay, because you're going to have to, like, to understand it, you're going to have to actually, like, really think here for a few minutes to figure it out, okay? We all good? You ready to learn? Okay. I want to know the values that are better to choose than the others. I'm going to tell you right now that this one is a bad choice, okay? That's a bad choice, and I'll show you why. If I flip back to my diagram here, whoop, that was from a different hour. Which one did we use? There we go, right here, okay. Tangent is when you take the y value and divide it by the x value, right? So what's the tangent of 0? Good, 0. Y value divided by the x value, what's the tangent of 90? Undefined. Okay, we got two of them. Obviously, you don't want to do the undefined result, right? So, like, don't choose 90 and 270. Everybody, we got that? All right, so then how about this one? Root of 2 over 2, root of 2 over 2. You divide those and you're going to get, ooh, that looks like a good option, doesn't it? Okay, this one, root of 3 over 2, divided by 1/2. If I multiply by the reciprocal, I get root of 3. Not as good as 1, but not bad, right? Look what happens if you do this one. You get 1/2 divided by the root of 3 over 2 times by 2 over the root of 3, and there you got. Those cancel. 1 over the root of 3 or the root of 3 over 3. Like, if there was one that you wouldn't want to use, which one would it be? Yeah, see how the 30-degree one is? It's not very pretty. This is not. And in fact, anywhere where you get a 30-degree reference angle, so 30 or 150 or 210 or 330, any of those will produce a positive or negative root of 3 over 3. So we want to stay away from those. We want to stay away from those. So I'm going to go back to this, and I'm going to write them down so you can see them. We'll work it through. You told me a tangent of 0 is 0. And if you want to write these down for your homework, you can. You don't get this on the test, but some people found this helpful. We said 30 would be the root of 3 over 3. 45 was 1. 60 was the root of 3. And 90 was undefined. I'll pause there. But those were kind of the main values we came up with. And then you're just going around the unit circle, so it just cycles back down. You're getting into the second quadrant, so it's tangent positive or negative in the second quadrant. It's negative. So the next one's just going to be negative root of 3, and then negative 1, and then negative root of 3 over 3, and then back to 0. See how it just cycles back down? And then we enter in the third quadrant, so tangent is going to be positive, so you're going to cycle back root of 3 over 3, 1, and root of 3, and undefined. And as you cycle back, we've got 300, you're going to have negative root of 3, negative 1, negative root of 3 over 3, and 0 again. So you can see very clearly by this picture that I've painted that we don't like to use 30, we don't like to use 150, we don't like to use 210, We don't like to use 330. And we don't like it when it's undefined either. So we've gotten rid of some options here. Do you want me to stand by it? So I've got 3 more options up here. Tell me which one's a bad option. 135 and 150. Stay away from it, folks. Don't use it. So, Caden, which one do you want to use? You got a choice. You pick which one. We don't care. 60 and 225. Let's go. Tangent of 285 is equal to the tangent of 60 plus 225. So I just took 285, separated into those two. Now we're going to expand it using the tangent formula. So I have the tangent of 60. What next? What does your formula say? Plus tangent of 225. 1 minus, good, is opposite sign. Tangent 60 times tangent 225. Good. So let's just figure out what that is. We produced a nice helpful tree for you over there. What is the tangent of 60? Root of 3. What is the tangent of 225? 1. Over 1 minus. The tangent of 60 is root of 3, and tangent 225 is 1. So really what we end up with is the root of 3 plus 1 over 1 minus the root of 3. Can I leave my answer like that? I can't, because I don't have a rationalized denominator. Anybody know what we do to rationalize the denominator? If you multiply by the root of 3, then that becomes 3, but that becomes the root of 3, right? And that becomes 3, and that becomes the root of 3. So we end up with another irrational number, don't we? So I got to get rid of a square root of 3. Spanish. We don't know how to do math, do Spanish. Yay, I love it. I love it. It's like let's just go, right? You don't know how to do math. You turn to Spanish. You say that in Spanish class, the teacher's like, what? You know what I mean? We're just going to math that right now. So we multiply by 1 plus the root of 3 over 1 plus the root of 3. When you don't know how to do it, you do the conjugate. That's what you're trying to say, weren't you? Yep. So I steal this conjugate piece. We've talked about it before, past couple days in class. Now we're going to multiply it out. Let's do the bottom. It's great when you multiply by the conjugate, because we multiply by conjugate, what happens in the middle? Vanishes. Great strategy. 1 times 1 is? Sweet. They're going to cancel, right? That's really nice. And then root of 3 times root of 3? 3, and it's going to be negative, so minus 3. So that's the bottom. Now we got to do the top. Now, no-wise, like the top, like nothing's going to cancel for the top, right? Well, let's look and see what we get here. 1 times 1 is 1. And then root of 3 times 1 and root of 3 times 1 gives us 2 roots of 3. And the root of 3 times the root of 3, 3. So 3 plus 1 is 4, plus 2 roots of 3, all over negative 2. Are both those divisible by negative 2? So let's go. We get negative 2 minus the root of 3. Oh, is that positive or negative? It's very negative, right? Which quadrant are we in? 285, 285 degrees. Fourth quadrant, 285. We're past 270, fourth quadrant. Is tangent positive or negative in the fourth quadrant? Tangent 285, and you get that thing. And if we try negative 2 minus the root of 3, notice how you get exactly what we thought. Take out your homework. Let's show you stuff you can work on and stuff you do not want to work on. Sorry, I'm trying to pull this up because I know people are going to be watching this one. I want to make sure they get this note that I'm going to put here. Okay. All right. For problems 1 through 8 that you see on the front, those are exactly like what we just did. So those are like example 2 and 3, I think, from your notes. Was there your notes? Was that 2 and 3? Is that what we had? Yeah. Okay, so it starts out where you can look at example 2 and 3 for these right here. Okay, so we got some sine, we got some cosine, we got some tangent problems. That example 2 and 3. Flip it over. These look really challenging. No, these should be easier. And these should be like example 1. So, like that looks familiar to your sine addition formula, doesn't it? So it ends up being the sine of 18 plus 27. What's 18 plus 27? 45, good. And the sine of 45 is? Root of 2 over 2. So these you can actually do pretty quickly along and look through those. Now, you do not need to do the proofs. It saddens me. Don't tell any of your teachers I took the proofs off, but because we missed Thursday and Wednesday of last week, something's got to go. Those go. Makes me very, very sad. We just did a proof of calculus today, and they all said, and I quote, "Wow, I didn't realize I liked proofs." You just haven't seen the right ones, folks. They're pretty cool. You don't believe me, do you? You don't. I had one person in second hour pull me aside after class and said, "I got to see it." I said, "What are you talking about?" I showed them. They're like, "That's really cool." Challenge accepted. It's easy.